dive in. We're talking all about erosion and sediment control today.
I love it.
And we always like to have some kind of source material to really like get our teeth into.
Yeah.
And this time, it's this really cool document that was put together by an inspector in South Carolina.
Nice.
And it's basically like a review and a primer on erosion and sediment control.
Cool.
Specifically for folks who are going to be working with construction site inspectors.
Oh, very cool. Very cool.
So, you might be thinking, South Carolina, what's that got to do with me?
Right.
But actually, a lot of the stuff in here is really universal.
Oh, for sure.
And I was really surprised by some of the things I learned reading through this.
Yeah.
So I think it'll be a really good deep dive for everyone.
Absolutely.
So why does this even matter? Why are we even talking about erosion and sediment control?
Well, I mean, it all boils down to water quality, right?
Yeah.
Keeping our rivers and streams and lakes clean.
Yeah.
And stormwater runoff is like the #1 cause of impaired waters in South Carolina.
Wow.
At least according to this document.
That's crazy.
Yeah, and it's not just South Carolina, right? This is a problem all over the country.
That totally makes sense.
And when you think about all the stuff that gets washed off of construction sites,
right,
it's no wonder that our waterways are struggling.
Yeah, and I think about like the fish and the other wildlife that depend on those clean waters.
Absolutely.
And it's kind of scary to think about what all that sediment and pollution is doing to them.
Yeah, for sure. And from a legal standpoint too,
right,
we have the Clean Water Act,
right,
which has a huge impact on construction sites all across the country.
Yeah, that's a big one.
So inspectors have a really important job, making sure that sites are complying with those regulations.
Totally. Yeah. So let's actually break down the difference between erosion and sedimentation.
Okay. So erosion is like the process of the soil actually being worn away,
okay,
by, wind or water or, whatever.
Right.
And then sedimentation is where that eroded material ends up.
Okay.
Human activities like construction contribute to 70% of the eroded sediment in the U.S.
That's crazy. 70%.
Yeah, it's a lot. Yeah.
Wow. Okay. So let's talk about the regulatory landscape surrounding all of this.
Okay.
Because obviously the Clean Water Act is the big federal law,
right,
that kind of governs all of this.
Mm-hmm.
But how does that actually play out on the ground in South Carolina?
Right. So the EPA sets the standards at the federal level.
Right.
But then each state is responsible for actually implementing and enforcing those standards.
Okay.
So in South Carolina, that's the South Carolina Department of Environmental Control.
Okay.
And they have a bunch of different regulations and permits and stuff that construction sites have to follow.
So it's like a federal framework, but with state-specific details.
Exactly.
Yeah. Cool.
And one of the most important things is the Construction General Permit.
Right. The CGP.
Or the CGP. Yeah.
Yeah. We'd love a good acronym.
Yes.
So when does a construction site actually need to get one of those?
So if you're disturbing an acre or more of land,
okay,
you're going to need a CGP. And even if your project is smaller than an acre,
right,
if it's close to a body of water, you might still need one.
Oh, interesting.
Yeah.
Okay, so it's not just about the size, it's also about the location.
Exactly, yeah.
Okay.
And the permit actually goes to the operator of the site.
Okay.
The person who's in day-to-day control of the construction activities.
Right.
The document calls them the primary permittee.
Okay, the primary permittee, got it.
Yeah, and that's the person who's ultimately responsible for making sure that the site is in compliance.
Okay, so that's good to know, as an inspector.
Right.
You know who to go to if there are problems.
Exactly, yeah.
Okay. So what about the Stormwater Pollution Prevention Plan?
The SWPPP.
Yeah, the SWPPP.
Yeah, so that's a really important document.
Right.
It's basically like a roadmap for how the site is going to manage stormwater runoff and prevent pollution.
Okay, so it's like their game plan.
Exactly.
Yeah.
And it has to be, very site-specific. It needs to identify all the potential sources of pollution on the site.
Okay.
And then outline the specific control measures that are going to be used to address those sources.
So it's not just like a generic template?
Right. It has to be tailored to that particular site.
Okay, got it.
Yeah.
So that's actually what inspectors are checking for. Right?
Yeah, exactly. They're making sure that the SWPPP is actually being followed.
Okay.
And that the control measures are in place and working properly.
So they're like the SWPPP police?
Yeah, pretty much.
Okay.
And, one thing that the document emphasizes is that the SWPPP has to be on site.
Okay.
At all times.
So it's not like something that you just submit to the state and then forget about.
Right. It needs to be readily available.
Got it.
For the inspectors to review and for the contractors to reference.
Okay, so inspectors definitely make a note of that.
Yeah.
Also, this document mentions a CEPSCI.
Yes.
What is that all about?
So that stands for Certified Erosion Prevention and Sediment Control Inspector.
Okay, that's a mouthful.
It is, yeah. It's a lot easier to just say CEPSCI.
CEPSCI.
Yeah.
Got it.
And basically, these are inspectors who have gone through, specific training
Right.
and have passed an exam
Okay.
to demonstrate that they have a really thorough understanding of erosion and sediment control principles and practices.
So they're like the elite squad of erosion and sediment control.
Yeah, you could say that.
Okay.
And, they're the ones who are really going to be making sure that those SWPPPs are being followed,
Right.
and that the site is in compliance with all the regulations.
So how often do those inspections actually happen?
So they need to happen at least weekly,
Okay.
and then also within 24 hours of any rain event that's over an inch.
Oh, wow. Okay, so they're out there pretty regularly.
Yeah, for sure.
And what are they actually looking for when they're doing those inspections?
So they're going to be looking at, all the disturbed areas on the site,
Right.
making sure that those areas are stabilized properly. They're going to be checking all the BMPs,
Right.
Making sure that they're installed correctly and that they're being maintained.
Right.
They're going to be looking at the discharge points,
Okay.
where the storm water is leaving the site,
Right.
making sure that there's no sediment leaving the site with that water.
So they're really covering all their bases.
Yeah, for sure.
And then obviously they have to document all of this, right?
Absolutely, yeah.
So what does that look like?
So they're going to be writing up reports,
Okay.
and those reports need to be very detailed.
Right.
They need to identify any BMPs that are failing.
Right.
They need to recommend corrective actions.
Sure.
They need to document all of their observations and findings.
So it's not just like everything looks good.
Right. It needs to be very specific and thorough.
Got it. Okay.
Yeah.
Well, let's actually dive into the BMPs themselves,
Okay.
because that's really like the meat and potatoes of all of this.
Yes.
And the document breaks them down into three main categories:
Right.
runoff control, erosion prevention, and sediment control.
Yep.
So let's start with runoff control, because I think that's kind of like the first line of defense.
Absolutely. Yeah.
So what are we talking about when we say runoff control?
So it's all about managing that initial flow of water.
Oh, okay.
Preventing it from picking up speed and carrying sediment off the site.
Right.
It's like taming a wild river.
Yeah.
You want to guide that flow where you want it to go.
Okay, I like that analogy. Yeah.
Yeah.
So what are some of the specific BMPs that fall under that runoff control category?
Okay, so first up we have pipe slope drains.
Oh.
These are basically like little water slides for runoff.
Okay.
They guide the water safely down a slope without causing erosion.
Okay, so it's like a controlled descent for the water.
Exactly, yeah.
Okay, cool. But I'm guessing there are things that can go wrong with those.
Oh, yeah, for sure.
So what should inspectors be looking for?
So one of the biggest things is pipe separation.
Okay.
Those pipes need to be connected and anchored securely.
Right.
Otherwise, you've got a potential erosion hazard right there.
Yeah, totally makes sense.
You also want to check for erosion at the pipe outlet.
Okay.
That concentrated flow of water can really create a gully if it's not managed properly.
Yeah, that makes sense.
Yeah.
What are some ways to prevent that outlet erosion?
So you can smooth the surface with riprap or a turf reinforcement mat.
Okay.
Basically, you want to create a buffer zone where the water can slow down and spread out
Right.
before it hits the surrounding soil.
Okay, so it's like a soft landing for the water.
Exactly.
Yeah. Okay, cool. I'm also guessing that clogged pipes are a common problem.
Oh, yeah, for sure. Construction sites can be messy places.
Right.
So inspectors should definitely check for blockages.
Okay.
And make sure that those pipes are flowing freely.
Got it. So it's about keeping those drains clear and functioning properly.
Exactly.
Okay, what's next on our list of runoff control BMPs?
So next up, we have runoff diversion measures.
Okay.
And these are all about redirecting clean water away from areas that are prone to erosion.
Okay.
It's like creating a detour for water.
Right.
Steering it away from trouble spots.
So instead of letting the water flow wherever it wants, you're giving it a designated path.
Exactly. Yeah.
Okay, cool.
Yeah.
And what are some of the common diversion structures that inspectors should be familiar with?
So dikes are a popular option.
Okay.
They're basically earthen berms that channel the water in a specific direction.
Right.
But dikes need to be compacted and stabilized.
Okay.
Often with erosion control blankets or turf reinforcement mats.
So those dikes need to be built to last.
Yeah, for sure.
What are some things that can go wrong with them?
So dike washouts are a common problem,
Oh, yeah.
especially during heavy rain.
Right.
That's why compaction and stabilization are so important.
Yeah, that makes sense. So
Yeah.
inspectors need to make sure that those dikes are holding up and doing their job.
Uh,
What about erosion behind the dikes?
Yeah, that's another issue to watch out for.
Okay.
Water can sometimes find its way around those diversions
Right.
and cause problems in areas that are supposed to be protected.
Sneaky water.
Yeah.
So how do you prevent that?
So stabilizing the area behind the dike is key.
Okay.
You might need to use additional BMPs
Right.
to reinforce the uphill side and make sure that the water stays where it's supposed to be.
Okay. Yeah, that makes sense. What about situations where you've got concentrated flow causing erosion? Are dikes the answer there?
Not always.
Yeah.
Sometimes you need to slow down that concentrated flow before it even reaches the dike.
Okay.
Check dams made of riprap or erosion logs can help with that.
So it's about breaking up that flow and giving the water a chance to spread out and slow down.
Exactly.
All right. So runoff diversion. It's all about guiding that water where you want it to go.
Right.
And making sure that your structures can handle the flow.
Yeah.
What's next on our list?
So construction dewatering. Okay.
This is all about removing water from excavations or work areas
Right.
so that construction can proceed.
So you're essentially draining the swamp so you can get to work.
Exactly, yeah.
Okay, cool. The way that water is discharged is obviously crucial.
Oh, absolutely, yeah.
So what are some things that can go wrong with dewatering discharge, and what should inspectors be looking for?
So one of the biggest issues is erosion caused by the discharge itself.
Okay.
That water often carries sediment,
Right.
and it can create gullies if it's not managed properly.
So it's not just about getting the water out of the way, it's about making sure that it's discharged in a way that doesn't cause more problems.
Exactly, yeah.
Okay. So how do you manage that discharge properly?
So installing outlet protection,
Okay.
like a riprap apron or an energy dissipator,
Okay.
can help to minimize that erosion.
Okay.
And inspectors should also be checking for sediment buildup in any treatment units that are being used.
Right. If those units get overloaded, they're not going to be effective.
Okay, so regular cleaning and maintenance of those treatment units is key.
Absolutely.
What about the flow rate of the discharge?
Yeah, that's another important factor.
Okay.
If it's too high, you could end up with erosion problems.
Twice.
If it's too low, the treatment system might not be working properly.
Okay.
It's all about finding that sweet spot.
So it's a balancing act.
Yeah.
You need to get the water out, but
Mhm.
you also need to make sure that it's being treated and discharged in a way that minimizes environmental impact.
Exactly.
Okay.
There.
Now, the document also mentions buffer zones as another runoff control BMP.
Right.
What are those all about?
So buffer zones are protected areas around surface waters.
Okay.
Think of them like a safety net,
Right.
filtering runoff and preventing pollutants from entering those sensitive areas.
So it's like a green barrier between the construction site and the water.
Exactly.
How wide do those buffer zones need to be?
So the standard is 30 feet around most bodies of water.
Right.
But for sensitive water, it bumps up to 45 feet.
Oh, wow. Okay, so it depends on the type of water body.
Yeah.
Okay. All right, so we've covered pipe slope drains, diversions, dewatering, and buffer zones.
Yep.
What's our last runoff control? BMP.
Flow control.
Okay.
So this is all about managing the volume and velocity of water runoff.
Good.
The goal is to slow it down and spread it out,
Right.
which helps to prevent erosion and allows sediment to settle out.
Okay, so it's like taming that wild water, making
Yeah.
it behave.
Exactly.
So what are some techniques for doing that?
So level spreads are a common method.
Okay.
They're essentially level walls that help to slow down the flow and disperse it more evenly.
Okay, so instead of having a concentrated stream of water, you're creating a wider, shallower flow.
Exactly.
Okay.
Riprap aprons are another common technique.
Okay.
They're basically layers of heavy stone that act as a buffer,
Right.
absorbing the energy of the water.
So it's like giving the water a cushion to land on.
Exactly.
Yeah.
Oh.
Okay. Any other flow control BMPs that inspectors should be aware of?
Well, there's one common misconception that I think is worth addressing.
Okay.
Silt fences are not meant for velocity control.
Really?
Yeah, a lot of people think that silt fences are all about slowing down water,
Right.
but their primary function is to trap sediment, not to control flow.
Got it.
So using them for velocity control can actually lead to them failing.
Oh, that's interesting.
Yeah.
Okay, so inspectors need to make sure that those silt fences are being used for their intended purpose. Okay, all right, so we've covered a lot of ground when it comes to runoff control BMPs.
We have.
Um, it seems like there are a lot of different approaches,
Yeah,
and each one has its own nuances and potential pitfalls.
for sure.
So it's really important for inspectors to have a thorough understanding of these BMPs
Absolutely.
and how they're supposed to function.
Yeah.
Um,
Okay, so let's move on to erosion prevention BMPs.
okay.
These are all about, keeping the soil in place,
Right.
preventing it from becoming that sediment that we're trying to control.
Yeah, so we've talked about managing the flow of water.
Right.
Now we're talking about protecting the source of the sediment itself,
Exactly.
like tackling the problem at its root.
Yep. And our first erosion prevention BMP is surface roughening.
Okay.
So this technique is all about creating texture on the soil surface.
Okay.
We're creating these little pockets and depressions that help slow down water flow and encourage infiltration.
So instead of having the water just sheet off a smooth surface,
Right.
you're giving it some obstacles to navigate,
Exactly.
making it soak into the ground instead of running off.
Yep. And this is usually done with heavy machinery.
Okay.
Creating horizontal depressions that run parallel to the contour of the land.
Oh, okay, so that's important.
It is, yeah.
Those depressions have to run parallel to the contour.
Right, because if those grooves run downhill, they actually accelerate erosion.
Oh, wow.
Yeah, so instead of slowing the water down, you're giving it a fast track right off the site.
So it's not just about roughening up the surface,
Yeah.
it's about doing it in a way that actually works with the natural contours of the land.
Exactly.
Okay, so inspectors need to have a keen eye for that.
For sure.
What's next on our list of erosion prevention BMPs?
So next up is temporary stabilization.
Okay.
Think of it like putting a blanket over any bare earth
Okay.
to protect it.
Makes sense.
Especially, on construction sites where areas might sit idle for a while.
Right, it's like a pause button for erosion.
Exactly.
How long can those areas sit idle before they need that protection?
So the general rule is that any area that's not actively being worked on for more than 13 days
Okay.
needs to be temporarily stabilized.
That 14-day rule, that's a good one for inspectors to keep in mind.
Yeah.
So what are we using for these temporary blankets?
So mulch is a popular choice.
Okay.
It's relatively inexpensive and effective
Right.
as long as you apply it to a minimum depth of 2 inches.
2 inches of mulch. Got it.
Yeah.
What about situations where you need something more robust than just mulch?
So that's where hydraulic erosion control products, or ECPs, come in.
Okay, HECPs.
Yeah. They're often used, with seeding,
Right.
and they're great for providing quick cover.
And most people know them from the term hydroseeding.
Exactly, yeah.
Okay.
But there are some limitations on where you can use HECTs.
Okay. What's
So
that?
they're not suitable for areas with concentrated flows.
Okay.
They're more for general surface protection.
So for those high velocity areas, you need to bring out the big guns.
Exactly.
What are we talking about?
So erosion control blankets, or ECBs,
Okay.
and turf reinforcement mats, or TRMs.
Okay, ECBs and TRMs, got it.
Yeah. ECBs are the temporary option.
Okay.
They're biodegradable.
Right.
They'll break down over time.
Okay.
TRMs are designed to be more permanent.
So you choose your weapon based on the situation.
Right.
And how long you need that protection to last.
Exactly.
Okay. But eventually you want to get to the point where the site doesn't need those temporary measures anymore.
Right. That's where final stabilization comes in.
Okay.
Full
Final.
stabilization.
Yeah, we're talking permanent vegetation.
Right.
Seeding, sodding,
Right.
or a combination of both.
So this is like the ultimate goal,
Yep,
to get that site green and growing again.
exactly.
And how do we know if we've achieved successful final stabilization?
So that's where the 70% density rule comes in.
Okay, the 70% density rule.
And this one trips people up all the time.
So it's not about 70% of the area having plants.
Okay.
It's about the density of those plants across the entire area.
Oh, okay. So it's like even coverage.
Exactly.
You need good, even coverage to really protect that soil.
Yep.
Okay, so inspectors need to make sure that those bare spots are addressed.
Right.
And that the vegetation is thick enough to do its job.
For sure.
What about situations where it's not just bare earth we're dealing with,
Right.
but actual channels or waterways that need stabilization?
So riprap is a go-to solution for those situations.
Okay, riprap.
Yeah. It's basically a layer of large angular stones that acts like armor plating,
Okay,
protecting those channels from erosion.
I love that visual.
Yeah.
But even with something as seemingly simple as riprap,
Right.
there's a right way and a wrong way to do it.
Oh, absolutely. Yeah.
What are some of the things that can go wrong with riprap installation?
So you need to install it correctly to be effective. A geotextile filter or granular underlayment needs to go underneath that riprap to prevent the soil from migrating up and clogging those gaps.
So it's all about those layers.
Yep.
Making sure that everything works together.
Exactly.
What about those spots where water discharges from pipes or culverts?
So that's where outlet protection comes in.
Okay, outlet protection.
Yeah, and you can use those same materials we talked about for channel stabilization.
Right.
Riprap, TRMs.
Okay.
Even gabion baskets.
Gabion baskets. Those are cool.
Yeah, those cages filled with rocks.
Yeah, I'm picturing it.
Yeah.
But no matter what you're using for outlet protection,
Right.
it's got to extend beyond the pipe itself.
Yep. You want to create a buffer zone on both sides of that pipe,
Okay.
upstream and downstream,
Right.
to prevent erosion from that concentrated flow.
Makes sense. Okay. So we've talked about surface roughening, temporary stabilization, a final stabilization riprap for channels, and outlet protection.
Right.
What's our last erosion prevention? BMP.
So polyacrylamide or PAM.
Payment. Okay.
Yeah, it's a non-toxic chemical that acts like a temporary glue,
Okay.
holding soil particles together and helping them settle out of the water.
So it's like a chemical helper for erosion and sediment control.
Exactly.
That's fascinating. And PAM comes in all sorts of forms.
It does, yeah.
Powder, liquid, even blocks.
Yep, you choose the form based on the application.
Okay, cool. All right, so we've covered a lot of ground when it comes to erosion prevention BMPs.
We have.
Are you ready to move on to sediment control?
Absolutely. Yeah, let's dive into those techniques for catching the sediment that's already on the move.
Okay, so we've talked about managing that runoff. We've talked about protecting the soil itself. Now let's talk about catching that sediment that's already on the move. What have we got?
All right, so one technique that's often used in detention basins is surface withdrawal.
Okay, so detention basins, those are those big ponds designed to hold stormwater runoff.
Exactly.
So how does surface withdrawal work?
So instead of letting that water flow out from the bottom of the basin, we're going to skim it off the top.
Oh, interesting.
Yeah, using a skimmer device.
So you're pulling the cleaner water off the surface.
Precisely. You're essentially giving that sediment a chance to settle out before that water is discharged.
Oh, okay, cool.
Yeah. Sediment basin is a more comprehensive system.
Okay.
It's designed to control both the quality and the quantity of that stormwater runoff.
So it's not just about holding the water, it's about actively removing that sediment.
Exactly. Think of it as a multi-pronged attack on sediment.
I like it. Okay. What are some key features of a sediment basin that inspectors should be looking for?
So first off, a sediment basin needs to be constructed before any grading takes place.
Okay.
Within its drainage area.
So it's like
And they also often include features like baffles or weirs to further enhance sediment trapping.
okay, baffles and weirs. Those sound pretty technical. What are those all about?
So think of baffles as walls that are placed within the basin to slow down the flow of water.
Okay.
Create those still areas where the sediment can settle out.
Okay.
Weirs
so it's all
are
about
openings that control
creating
the
this
water level.
obstacle course for that sediment,
Exactly.
giving it as many chances as possible to settle out.
Yep.
Love it. Okay, how are sediment dams or traps different from sediment basins?
So they're similar in concept, but sediment dams are smaller and more localized.
Okay.
They're essentially barriers made of stone or other materials
Okay.
placed across a channel or spillway to intercept sediment.
So they're like mini dams,
Exactly.
trapping that sediment in smaller areas.
Yeah.
Okay. What should inspectors keep in mind when looking at these dams?
So they need to make sure that the sediment is being removed periodically. The general rule is to remove it when it reaches about 50% of the dam's capacity.
Got it.
Otherwise, the dam can become overloaded and ineffective.
You don't want those dams to become sediment mountains.
Exactly.
Okay, what's next on our list of sediment control BMPs?
Rock sediment dikes.
Okay.
Think of them like elongated speed bumps for water.
I like that.
Slowing it down, encouraging sediment deposition.
So they're not actually dams, but more like elongated mounds of rock
Right.
placed strategically.
Yeah, and they're often placed in a semicircle shape
Okay.
to spread out that concentrated flow.
Okay, so they're disrupting the flow and encouraging the water to drop its sediment load.
Exactly.
Love it.
Yeah.
Okay, I think it's time we talk about one of the most iconic sediment control measures, the silt fence.
The trusty silt fence.
Right.
They're everywhere on construction sites.
Yeah, they are.
And for good reason.
Those black fabric fences, hard to miss.
Yep.
I'm guessing there's more to it than just putting up a fence.
Oh, yeah, absolutely. Proper installation is key for these to work correctly.
Okay, so what does proper installation look like?
So the bottom of that fence needs to be buried
Okay,
and compacted into the soil.
so it's not just flapping in the breeze.
Nope, it's anchored in place.
Okay,
And that fence also needs to be perpendicular to the flow of water.
right, not parallel.
Exactly. So that way it intercepts the runoff and traps that sediment.
Okay, so placement and orientation are key.
For sure.
What about maintenance?
Right. So you need to remove sediment when it reaches about 1/3 of the fence's height.
Okay,
Otherwise, the fence will overtop and all your hard work will be for nothing.
so inspectors need to be on the lookout for sediment buildup.
Yep.
Make sure those fences are being maintained.
Exactly.
Okay, silt fences are great for general sediment control, but what about situations where you've got concentrated flow in a ditch or a channel?
That's where rock ditch checks come in.
Okay, rock ditch checks.
Think of them like mini dams made of rock placed in those ditches and channels.
Okay,
Slow the flow,
okay.
promote sediment settling.
So they're like a more heavy-duty version of those sediment dams
Exactly.
we talked about earlier. Are there any special considerations for installing these rock ditch checks?
Yeah, so the center of that check dam needs to be lower than the outside edges.
Okay,
That helps to direct the water towards the middle of the channel,
okay.
encouraging sediment deposition and preventing erosion along those sides.
So it's all about manipulating the flow
Yep,
to get that sediment to drop out.
exactly.
Are there any areas where rock ditch checks are not allowed?
Absolutely. So they should never be placed in blue line streams.
Okay,
Those are perennial streams and they get special protection. Sediment tube ditch checks are a good option.
okay. Sediment tube ditch checks.
Yeah, they're flexible tubes filled with a sediment trapping material,
Okay.
kind of like giant socks that filter the water.
I love that analogy. So they slow down the flow trap, the sediment, while still allowing some water to pass through. That's pretty ingenious.
Yeah.
Okay, let's shift gears a bit and talk about preventing that sediment from leaving the construction site in the first place.
All right, one of the most important measures for that is a stabilized construction entrance.
Okay.
All those vehicles coming and going from the site
Right.
can track a lot of mud, and that can end up polluting nearby waterways.
It's like a mud conveyor belt.
It is, yeah.
The solution.
A stabilized construction entrance,
Okay.
heavy-duty pad made of stone or other durable material,
Okay.
placed at those entrance and exit points of the site.
So it's like a giant doormat for those construction vehicles,
Exactly.
giving them a chance to clean their wheels before they hit the public roads.
And there are specific guidelines for these entrances.
Okay.
So they should be at least 24 feet wide and 100 feet long,
Okay.
with a minimum depth of 6 inches.
Got it.
And here's an important detail. You need to use a geofabric layer underneath that stone.
Oh, why is that?
So it prevents the sediment from migrating up through the stone and ending up on those tires anyway.
Oh, so it's like an extra layer of protection.
Exactly. It's all about those layers,
Yeah.
creating a system that really works.
So it's not just about throwing down some gravel. There's a science to it.
There is.
Okay. Let's talk about those stormwater inlets.
All right.
They seem particularly vulnerable to sediment pollution.
Yeah, those inlets are like gateways to our waterways.
Right.
And we have several options for protecting them.
Okay.
One is filter fabric inlet protection.
Wait.
Temporary fabric barrier
Okay.
acts like a filter catching sediment before it enters the inlet.
So it's like a strainer for stormwater.
Exactly.
But are there any limitations to filter fabric protection?
So it's best suited for low velocity areas.
Okay.
If you've got a lot of water rushing toward that inlet, the fabric might not be able to handle it.
So for higher velocity situations, we need to bring in the reinforcement.
Exactly. Hardware fabric and stone inlet protection is a good option for those areas.
Okay, so it's like a reinforced filter.
Yep.
Able to withstand those heavier flows.
And the document mentions that this type of inlet protection is particularly useful in areas with heavy traffic.
Yeah, that makes sense. The
Let me-
stone helps to withstand the wear and tear of vehicles driving over it.
Exactly.
Okay. What about those preformed inlet protection devices that we see everywhere on construction sites?
Yes, those prefabricated inlet protection devices, they come in all sorts of shapes and sizes.
Yeah.
And they're designed to fit snugly around inlets, grates, and curb cuts.
Yeah, I've seen those. They look like giant socks or bags filled with filter media.
Exactly. Some common examples are dandy sacks and erosion eels.
Okay.
Super convenient and very effective at preventing sediment from entering those inlets.
All right, so we have a whole arsenal of options when it comes to inlet protection.
We do.
Okay. Well, we've covered a lot of ground today, from runoff control to erosion prevention to sediment control. I'm starting to feel like a BMP expert.
I think you are.
But knowing about these BMPs is only half the battle, right?
It's true. It all comes down to those field inspections.
Right.
What good are all these BMPs if they're not being implemented and maintained properly?
Exactly. So what are some key things that inspectors should be looking for when they're out in the field?
So the document highlights 5 key questions that every inspector should ask.
Okay, hit me.
First and foremost, does this project even have an approved permit?
Okay, so it seems basic, but
You'd be surprised.
yeah, you'd be surprised how often that gets overlooked.
Exactly.
Okay, so it's about verifying that everything is legit from the get-go.
Right.
What's the second question?
Are the erosion and sediment control measures installed and being maintained as shown on the approved plan?
So inspectors need to compare the SWPPP to what's actually happening on the site.
Exactly. Are the BMPs in the right locations?
Right.
Are they installed correctly? Are they being maintained properly?
So it's about making sure the real world aligns with the plan, no cutting corners.
For sure.
What's next?
The third question is erosion being controlled on the site?
Okay.
Are those erosion prevention BMPs doing their job? Are there any signs of active erosion?
Okay.
Gullies, rills, exposed soil.
So it's about assessing the overall effectiveness of those measures.
Exactly.
What about question number 4?
Is sediment being contained on the site?
Okay.
This is where those sediment control BMPs come into play.
Right.
Are the silt fences holding?
Right.
Are those sediment basins functioning properly? Are those rock ditch checks doing their job?
So it's about making sure that sediment isn't escaping and causing problems downstream.
Exactly.
What's the final question?
Are any adjacent properties or state waters being impacted?
Okay, so this is about looking for off-site impacts,
Exactly.
especially in those lower elevations where that sediment-laden water might be flowing.
Yeah.
So it's about thinking beyond the boundaries of the construction site itself and considering the bigger picture.
For sure.
Okay.
Yeah.
The document also outlines some specific responsibilities for inspectors. What are those?
So inspectors need to create a link between the approved SWPP and its implementation. Make sure those BMPs are being maintained properly,
Right.
and recommend any additional practices if needed.
So they're not just passive observers.
Nope.
They're active participants in the process.
They're the eyes and ears on the ground,
Exactly.
making sure that those BMPs are doing their job.
And we know those inspections need to happen weekly with additional inspections after heavy rain.
Right.
But what are some specific things that inspectors should be looking for during those site visits?
So first, they need to take note of the surrounding areas,
Okay.
especially those nearby water bodies.
Right.
Are there any signs of sediment deposition?
Okay.
Is that water cloudy or discolored?
So they're looking for those telltale signs of sediment transport.
Exactly. What else should they be paying attention to? The weather conditions?
Okay.
Has there been recent heavy rain? Is there potential for erosion or sediment transport based on the current forecasts?
So it's not just about what's happening right now, but also about anticipating what might happen in the future.
Exactly. The phase of construction is another important factor.
Right.
Different phases will have different erosion and sediment control needs.
Right. Okay.
They should also pay close attention to that construction entrance. Is it functioning properly? Is it preventing sediment from being tracked onto public roads?
Makes sense.
And they need to walk the perimeter of the site,
Okay.
looking for any signs of off-site impacts, especially in those lower elevations.
So they're really covering all their bases.
Yeah, for sure.
Now, all this observation is great, but it's useless if it's not documented.
Right.
So what are some key things that inspectors need to record?
So they need to notify the primary permittee of their findings.
Okay.
Communicate any issues with project managers and foremen.
Right.
Keep the regulatory authority informed of any major problems.
Okay.
And of course, maintain detailed records within that SWPPP document itself.
So it's about communication accountability and creating a clear record of what's been observed and what actions have been taken. Well, we've covered a lot of ground in this deep dive into erosion and sediment control.
We have, I think our listeners are now well equipped to tackle those training sessions.
Yeah.
They've got the knowledge, the insights, the practical tips to make a real difference in the field.
Absolutely. Remember, this isn't just about checking boxes and following rules. It's about protecting our precious water resources and making sure that construction projects are carried out in an environmentally responsible way.
Couldn't have said it better myself.
So as always, we appreciate you joining us for this deep dive into erosion and sediment control. We'll catch you next time.